Hello everybody, welcome to my Python YouTube channel. In this video I will show to you how to create and add a uniform noise to any image. First of all, what is uniform noise? A uniform noise is a random number that follows a uniform distribution. This image is the example of uniform noise, and if you plot the histogram of this image, it will look like this one. The minimum number A is 0 and the maximum number B is 0.2. As you can see in this figure, the frequency of any number between 0 and 0.2 is the same. This kind of distribution is called as a uniform distribution. In Python, we can use the numpy.random.uniform built-in function to create the uniform noise. Alright, that's some background about the uniform noise. Let us now move to Spider IDE and I will show to you how to do all of this process using Python. Alright, here I am in the Spider IDE. Let us import some libraries. So in this line of code here, I open the image using cv2.imread. Here, the second variable I set 0. This is basically tell this cv2.imread to open the image as a grayscale image. Next, I normalize the image by dividing with 255 or the maximum pixel value. So after I normalize, our image here will have value from 0 up to 1. Next, this is an optional. If you want, you can display the image using the cv2.imshow. Alright, so this is our original image and we will add a noise into this image. Alright, let us now create our uniform noise. So the line 20 here, basically we just take the total number of row and column from our image. So here the x is 512 and y is 512. Next we set the minimum number or variable a as well as the maximum number or the variable b for our uniform noise. And here we create a matrix that has value 0 and the size is x by y. And if we open this variable n, this is a two-dimensional matrix that size is 512 by 512. And initially the value is 0. Next we will change this all of this value using the numpy random.uniform. Okay, let's run this line of code. Alright, as you can see here, previously all the value here is 0, and after we will run this line of code, we change the value with a random number between 0 and 0.2. And if we display using the cv2.imshow, our noise image will look like this one. Alright, now we will add the noise to our image. For now, let us ignore this line 34 and we jump here to display our image with noise as well as our original image. Alright, so this is our original image and this one is the image after we add a uniform noise. Next, line 41 up to 57, we plot the histogram of our original image, the uniform noise, as well as image with a noise. Okay, let us run this code. Alright, so this is the histogram of our original image, this is the histogram of our uniform noise, and histogram from our image with a uniform noise. If you see here, some pixel will have value larger than 1, and will become a problem when we want to save our image with noise using the cv2.imWrite function. Therefore, we will need this line of code here to clip or change any pixel value larger than 1 to 1. Okay, let's run this line 34 here. Alright, so now our image with noise will have maximum value up to 1. Next, if you want to save this image using the cp2.imread function, first you need to convert the type of our number from float 64 to unsigned integer 8, or it's called as t8, something like that. Therefore we need this function image underscore as ubyte. So this function will automatically convert this float 64 to unsigned integer 8. That's why we import this function here. Now let's run this code to save our image. Alright, we successfully saved our uniform noise as well as our image with a noise. That's all from this video. If you want to download this Python code, you can visit my GitHub repository. I put the link in the description. Thank you for watching and see you on the next video.